The cosmic enigma of 3I/Atlas, a visitor from beyond the stars. Imagine a cosmic intruder tearing through our solar system, defying every rule we thought we knew about the universe. On July 1st, 2025, a new interstellar object, 3I/Atlas, burst onto the scene, captivating astronomers and sparking wild speculation. This isn't just another space rock. It's a celestial mystery that's rewriting the playbook on comets, challenging our understanding of physics, and leaving even NASA's top minds scrambling for answers. Buckle up because this story is a wild ride through the cosmos, and you won't want to miss a single moment. Stick with me until the end, and don't forget to subscribe for more mind-blowing cosmic discoveries. The discovery, a cosmic bullet caught in the act. Picture this, a quiet night at the Atlas Survey in Chile, where telescopes scan the heavens for anything out of the ordinary. On July 1st, 2025, they locked onto something extraordinary, a blazing object hurtling through space at a jaw-dropping 130,000 miles per hour. Designated 3/Atlas, it became only the third confirmed interstellar visitor to our solar system, following the enigmatic 1I/Oumuamua in 2017 and 2I/Borisov in 2019. NASA's press office didn't waste a moment, releasing details within hours that sent shockwaves through the astronomical community. This wasn't just fast. It was moving with a trajectory so bizarre that astronomers double-checked their calculations, unable to believe their eyes. What made 3I/Atlas stand out wasn't just its speed, but its path. With an orbital eccentricity of 6.141, it holds the record for the most hyperbolic trajectory ever observed, meaning it's not just passing through, it's barely bending as it rockets through our solar system. Unlike typical comets that loop around the sun, 3I/Atlas is on a near straight shot, like a cosmic bullet fired from another star. But the real kicker? A bright, persistent plume pointed toward the sun, defying everything we know about comets. Telescopes like Gemini South and the Lowell Discovery Telescope captured this anomaly in stunning detail, revealing a sunward arc that refused to behave like any comet tail in history. This wasn't just a discovery, it was a challenge to our understanding of the cosmos. The composition, a chemical cocktail from another world. As astronomers raced to unravel the mystery, the James Webb Space Telescope, or JWST, turned its powerful spectrograph on 3I/Atlas in early August 2025, revealing a chemical makeup that left scientists stunned. Most comets in our solar system have a carbon dioxide to water ratio between 0.1 and 2, with rare outliers reaching 4. But 3I/Atlas? Its ratio clocked in at an astonishing 8, with an uncertainty of plus or minus 1, placing it 4 standard deviations above the norm. Only one other comet, C/2016 R2, has come close, and it's considered a freak of nature. The JWST team, led by Martin Cordner, confirmed the measurements at 3.3 astronomical units from the Sun, noting that the carbon dioxide signature at 4.3 microns dwarfed the waterline at 2.7 microns. Carbon monoxide trailed behind at a ratio of 1.4 to water, but the real surprise was the sunward dominance of carbon dioxide, perfectly aligned with the mysterious plume. The Very Large Telescope in Chile added another twist, detecting atomic nickel in the coma at a production rate of 10 to the 22.67 atoms per second, a massive output for a comet so far from the sun. Stranger still, no iron vapor, typically found alongside nickel, was detected, making 3I/Atlas's chemistry unlike anything in our solar system. These observations are hard facts, meticulously recorded and verified by multiple observatories. But what do they mean? The high carbon dioxide and nickel suggest 3I/Atlas formed in a distant, alien environment, possibly around a carbon-rich star or in a region with unique chemical processes. The absence of iron and the sunward plume hint at forces or materials we don't yet understand, setting the stage for heated scientific debates. The trajectory, a path too perfect to be chance. If the chemistry wasn't strange enough, 3I/Atlas's trajectory is downright eerie. It's moving in a retrograde orbit, nearly aligned with the ecliptic plane, tilted just 5 degrees from Earth's path, a configuration with less than a 0.2% chance of occurring randomly. Orbital dynamicists crunched the numbers and found the odds of this alignment at roughly 2 in 1,000. Most interstellar visitors slice through our solar system at steep angles, but 3I/Atlas slipped in almost parallel to our orbit, moving in reverse. Its path will bring it within 29 million kilometers of Mars on October 3rd, 2025, 97 million kilometers of Venus a month later, and 54 million kilometers of Jupiter a month after that kilometers of Jupiter in March 2026. The odds of threading this cosmic needle, passing so close to 3 planets, are less than 1 in 20,000. But the trajectory data holds an even deeper mystery. By August 2025, astrometric teams at Lowell and Gemini South noticed the gravity-only model, based on an eccentricity of 6.141 and an excess velocity of 58 kilometers per second, was drifting. The residuals grew to 0.7 arcseconds, more than double the expected scatter, and they weren't random. They shifted sunward, aligning with the plume's axis. Adding a tiny sun-directed acceleration of 4 times 10 to the -7th meters per second squared improved the fit dramatically, suggesting a force equivalent to 0.44 millinewtons, comparable to a spacecraft's ion engine. This isn't speculation, it's measurable data, confirmed across multiple observations. But what's causing this acceleration? That's where the line between fact and theory blurs, and the possibilities get wild. Possible implications: a natural wonder or something more? Let's talk about that sunward plume, because it's the heart of the mystery. Comets follow a simple rule. Solar radiation acts like a cosmic wind, blowing dust and gas away from the sun, creating the iconic comet tail. Think of a car speeding through a rainstorm. The rain hits the windshield, but the spray trails behind, caught by the wind. For 3I/Atlas to spray material toward the sun, it would need to overcome the relentless push of solar radiation. Hubble's high-resolution images from late July 2025 confirmed the plume's blobby, persistent arc, stretching directly toward the sun from the nucleus's sunlit face. Dust dynamic simulations, adjusting for particle size, velocity, and solar wind strength, failed to explain it. The dust is too heavy to be swept back, yet too energetic to fall straight down. Could this be a natural phenomenon? Scientists have tested ideas like spinning nuclei or supervolatile ices, but none replicate the plume's shape and persistence. The force required to push dust sunward is orders of magnitude higher than typical cometary outgassing. This is where speculation creeps in. Harvard's Avi Loeb, no stranger to bold ideas, has suggested the plume resembles an ion thruster's exhaust, like those used on NASA's Dawn spacecraft. Ion drives produce a narrow collimated stream of charged particles, and 3I/Atlas's plume, with its heavy, clumpy dust and sunward focus, fits the profile unnervingly well. Could this be evidence of an artificial object? Before you jump to conclusions, consider the data. No xenon, a common ion drive propellant, was detected. Instead, we see carbon dioxide and nickel, both of which can be ionized under certain conditions. The idea of an alien craft is tantalizing, but natural explanations, like an unknown outgassing mechanism, are still on the table. Scientific debates, nature versus nurture in the cosmos. The scientific community is buzzing with theories about 3I/Atlas, and the debate is as fiery as the object itself. On one side, researchers like Bryce Boland argue for a natural explanation, pointing to the comet's chemical anomalies as evidence of an exotic formation process, perhaps in a distant star system with unique conditions. The high carbon dioxide and nickel could indicate a nucleus formed in a carbon-rich environment, while the sunward plume might result from an undiscovered volatile or magnetic interaction. These theories are grounded in known physics but stretch our understanding of cometary behavior. On the other side, mavericks like Avi Loeb push the boundaries, suggesting 3I/Atlas could be a relic of extraterrestrial technology, The sunward acceleration, mirroring an ion thruster's thrust, and the precise trajectory raise eyebrows. Loeb points out that a sunward maneuver during perihelion could leverage the Oberth effect, a tactic used by spacecraft to maximize efficiency. But without evidence of artificial materials like xenon, this remains speculative. The truth likely lies in a gray area. 3I/Atlas could be a natural object with unprecedented properties, or something we can't yet categorize. What's clear is that it's forcing scientists to rethink the rules of comets and interstellar visitors. Cultural context, a cosmic mirror for humanity. Why does 3I/Atlas grip our imagination? It's more than just a space rock. It's a reminder of how little we know about the universe. The discovery echoes the frenzy around 1I/Oumuamua, which sparked debates about alien technology and inspired books, podcasts, and even movies. 3I/Atlas, with its defiant plume and alien chemistry, taps into our collective curiosity and fear of the unknown. Are we alone? Could this be a sign of something greater? These questions aren't just scientific, they're deeply human, reflecting our desire to find meaning in the cosmos. Social media platforms like X are ablaze with reactions, from amateur astronomers sharing telescope images to conspiracy theorists claiming 3I/Atlas is a cloaked alien probe. The truth, as always, is more nuanced, but the excitement is undeniable. The Vera Rubin Observatory, set to detect more interstellar objects at a rate of one per year, promises to fuel this fascination. Each new visitor is a chance to peer into the galaxy's past, to uncover clues about the stars and systems that birthed these wanderers. 3I/Atlas isn't just a scientific puzzle, it's a cultural phenomenon, a cosmic mirror reflecting our hopes, fears, and insatiable curiosity. Conclusion, the mystery continues. As 3I/Atlas approaches its perihelion on October 30th, 2025, it will slip behind the sun, entering a blind spot where no telescope can follow. This moment of maximum kinetic energy is critical. For a comet, it's when outgassing peaks. For a hypothetical spacecraft, it's the perfect time for a maneuver. Planetary defense teams and observatories like Vera Rubin are on high alert, ready to track 3I/Atlas when it reemerges. Will its plume intensify? Will its trajectory shift again? The answers could redefine our understanding of the universe. This isn't the end of the story, it's just the beginning. 3I/Atlas is a cosmic wake-up call, a reminder that the galaxy is full of surprises. Whether it's a natural wonder or something more, it's pushing the boundaries of what we believe is possible. So what do you think 3I/Atlas could be? Is it a comet like no other, or a hint of something extraordinary? Drop your thoughts in the comments below, hit that subscribe button, and stay tuned for updates as we chase this interstellar enigma. The universe is calling, let's answer it together. Engaging question for comments. What's your wildest theory about 3I/Atlas? Is it a natural comet, an alien artifact, or something we haven't even imagined? Share your ideas in the comments and let's spark a cosmic debate.